So once again, welcome to Embedded Systems 2, and in this last video in this series of interfacing videos, we're going to look how to connect or interface an LM35 temperature sensor through an analog to digital converter to the PIC16F84 microcontroller, and we're going to try and display the temperature that's been read in from the temperature sensor, the LM35 temperature sensor, on a liquid crystal display. So if we look at the top half of this slide here, we can see that we've got port B. And port B has two registers, the TRIS B register, which is loaded with 8 zeros, setting up port B as an output port. And the 8 lines that are available on port B, we're using some of these lines to interface to this liquid crystal display. And on this liquid crystal display, I want to display the temperature reading, so the temperature is 21 degrees. Now, as I said in the previous video, that is done almost automatically for us. We have a printed circuit board pre-built, we plug it into port B of our PIC microcontroller, and all the wiring that I've shown on the top half of this slide is done for us. Now, it's a different situation down in the bottom half of this slide. On the bottom half of the slide, I have two components that I want to connect to my port A of my PIC microcontroller. So here's the TRIS A register, which is set up with 7 zeros and a logic 1. So that's 01 hexadecimal, or the number 1 in decimal if you like. So that has to happen. And I'm going to use 3 of these lines, PA0, PA1 and PA2, to connect my analog to digital converter, the TLC548, to the PIC microcontroller. So pins 6, 7 and 5 of my analog to digital converter are connected to pins 17, 18 and 1 of my PIC microcontroller. Now unfortunately I don't have a pre-built printed circuit board for this. I'm going to have to build this on breadboard and somehow wire it to port A. And we'll be looking at how that's done in our lab sessions. We'll also look at a simulation of this in Proteus, which is a little bit easier to work with, and we'll see that this actually does work. So this is my analog to digital converter. Now in a previous video I spoke about this analog to digital converter, and I told you that there was 8 pins, all of which have to be wired to something. And these are all the connections that have to be made on the breadboard. I have to connect pins 8, 6, 7, 5, 3, 4, 2 and 1 to some other component. Now pins 8 is connected to 5 volt, pin 4 is connected to ground, and pin 3 is connected to ground. So I have 2 grounds, the reference minus and the ground, and I've also got pin 8, which is going to be connected to 5 volts. Pin 7, 6 and 5 are used to control the analog to digital converter, and they are used by port A of the PIC microcontroller. So that's some of the pins. I have to set up a reference voltage with an analog to digital converter. I want that pin 1 to be 2.55 volts, and I'll explain in another video why that is. So I'm setting this reference voltage to 2.5 volts. Out here I have a temperature sensor. I've got the simplest and most robust temperature sensor I could find, which is the LM35 temperature sensor. Pin 1 has to be connected up to 5 volts. Pin 3 has to be connected to ground, and pin 2 has to be connected to the analog input of the analog to digital converter, which happens to be pin 2 as well. So this is a 3-pin device, and you'll see this on my breadboard. This is an 8-pin device, and it all has to be wired up together as shown here, and then wired back to port A. Very simply, what's going to happen here is this temperature sensor will read the temperature in the room. It will send a voltage that represents that temperature to the analog input pin of the analog to digital converter. The analog to digital converter will convert that analog voltage to a digital signal. That digital signal is then converted into a temperature inside in the PIC microcontroller, and we need to write a program to do that. And then port A is used to display that temperature on the liquid crystal display. So that's how you interface an analog to digital converter and a liquid crystal display and temperature sensor together. And this is probably one of the more complicated circuits that we've looked at in the first half of Embedded Systems 2. Okay folks, we'll leave it there. Thanks for listening.